I want you to imagine integrating your health app with EHR and EMR systems. Seems complex, doesn't it? But with the right process, it's completely manageable. In this video, we'll walk you through step by step from planning to deployment, showing exactly how you can connect your app to major healthcare systems securely, efficiently, and at scale. Now, every successful integration starts with understanding what you need to achieve. So identify the EHR or EMR systems your app is going to connect with. Determine the types of data you'll need: patient demographics, lab results, prescriptions, claims, clinical notes. Map workflows and processes. How should data flow between the app and the EHR? And also review regulatory requirements like hipaa, HITAC, GDPR, and the ONC Cures Act. Make sure you involve your project manager, integration architect, and clinical stakeholders to capture all requirements up front. Next, design the integration blueprint. This defines how your app talks to the EHRs. Decide whether to use direct API calls or a middleware platform. Middleware like MuleSoft, Redux, or Rhapsody helps with data normalization, error handling, and multi-vendor orchestration. Select integration standards: FHIR for modern modular resources, HL7 for traditional messaging, Smart on FHIR for patient-facing apps. Define data mapping and transformations. Structured data like labs map to LOINC codes, medications to RX norm, and clinical notes can use NLP for unstructured content. Plan for authentication and authorization. OAuth 2.0, RBAC, and consent management ensure secure access. And lastly, prepare an event-driven architecture if you need real-time updates or batch transfers for periodic data sync. The output is a comprehensive architecture diagram showing systems, data flow, security layers, and error handling points. Now, before touching real patient data, it's crucial to build and test a prototype in a sandbox. So this means use synthetic patient data to simulate workflows, connect to EHR vendor sandboxes to validate APIs and authentication, test key workflows like patient updates, lab results, and claim submission, and ensure middleware correctly transforms and routes the data. This sandbox stage will reduce risk, identify errors early, and ensure your app and integration logic worked all as expected. Now, with the prototype validated, build the actual integration workflows. So implement ETL pipelines, API connectors, and transformation logic. Set up the authentication flow, so OAuth, token handling, role-based access, and consent enforcement. Develop error handling and retry mechanisms. Configure logging, monitoring, and observability to track every data transaction, and integrate administrative workflows, so claims processing, scheduling, billing, or prescription management. This phase turns the design into a fully functioning integration ready for rigorous testing. Now, testing ensures integration is secure, reliable, and accurate. So make sure you have unit tests, validate individual API calls and FHIR HL7 resources. Integration tests, confirm workflows between the app and EHR all work. Also, integration tests, confirm workflows between the app and EHR work end-to-end. Load tests, simulate high-volume data to check performance and latency. Security tests, ensure OAuth scopes, RBAC, and encryption are properly enforced. And of course, regression tests, verify updates don't break existing functionality. Testing and staging, or pre-production environments, mirrors the production setup, ensuring readiness before going live. Now, before rolling out to all users, deploy a pilot version at a limited facility or subset of users. Here, monitor KPI metrics, API latency, workflow success rate, error rates, and patient data availability. Collect feedback from clinicians and administrative staff, and adjust workflows, middleware settings, and notifications based on real-world usage. A successful pilot ensures a smooth, full-scale rollout with minimal disruption. After a successful pilot, it's time for full production deployment. Use deployment strategies like blue-green releases, canary deployments, or feature toggles for a safe rollout. Continuously monitor API performance, system resources, and workflow KPIs. Maintain audit logs, consent management, and role-based access controls, and have rollback and contingency plans ready in case of unexpected issues. At this stage, your health app is fully integrated, delivering real-time patient data, automated workflows, and secure access to all users. Now, integration isn't over after deployment. Continuous monitoring and optimization are key to maintaining success. Track administrative efficiency, claims processing time, real-time data availability, and workflow automation coverage. Use observability dashboards with automated alerts for anomalies. Optimize performance, add new workflows, and expand integration to additional facilities as needed. This ensures your health app continues to deliver value, reliability, and compliance over time. And keep your integration future ready. So explore AI and ML for automated coding, clinical insights, and predictive analytics. Enable patient-owned records and granular consent. Integrate IoT devices and wearables for real-time monitoring. Leverage FHIR bulk data for population health analytics. Consider blockchain for immutable audit trails and secure consent enforcement. By staying ahead of trends, your health app becomes a trusted, scalable, and innovative partner for healthcare providers and patients alike. At OSP, we specialize in turning complex EHR integrations into seamless, reliable solutions. From discovery to production and beyond, we guide you every step of the way, ensuring your health app delivers real-time data, workflow automation, and compliance effortlessly. Let's build your next generation health app together.